Okay friends, today I am going to discuss about magnetic resonance, which is the technique which is used in magnetic resonance imaging, that is also known as MRI, which is used in medical purpose mostly. So today I am going to discuss about that. Okay, let's begin our topic of today. So magnetic resonance is most commonly used in that medical purpose, for the detection of various injuries and wounds in our body. So, what is the theory behind it? This is done due to the application of magnetic field. So, how it is done? Let's begin. Magnetic resonance is the process that is used in magnetic resonance imaging. Means by the use of this magnetic resonance, the image of the patient's or the person uh, internal organs is found. Uh, okay. In this case, while doing this, the strong static magnetic field is applied in z direction. Uh, Strong static magnetic field is applied in z direction, and the small oscillating magnetic probe or oscillating magnetic field is applied in x direction. So the total magnetic fields component acting in the localized electron are. So if the electron is in space or somewhere, then the total magnetic fields acting on it are strong static magnetic field is acting in z direction, which is very large. Likewise, a very small oscillating magnetic field, which is commonly known as probe, is applied along x direction, and there is no magnetic field along y direction. Okay, in the previous section we have obtained the expression for Hamiltonian of electron due to magnetic field. Yes, before I have already discussed about the magnetic uh, Hamiltonian effect on Hamiltonian due to the presence of magnetic field. Uh, and in the case of this magnetic resonance, we study about the intrinsic property of electron. So we will consider here the Hamiltonian due to spin. Okay, so we have done here likewise. Yes, yes, Hamiltonian due to spin is equal to EGS divided by 2mcb. This we have already derived, where E, this absolute E, defines the charge of electron, and G is Lambda splitting factor. This S is spin, okay, and 2, that is factor already found. M, mass of electron, C, speed of light, dot B, magnetic field. Uh, we can convert this S into in the form of Pauli spin matrices also. According to Pauli, what he have used, he have used S equal to h squared by 2 sigma r naught. So in place of S we have used h squared by 2. So here already 2 is here, so it becomes 4, and in place of S here comes sigma and h squared from this. So we can get this from this, and here sigma dot b means we have to do the dot product of sigma and b. So here magnetic, this sigma is Pauli spin matrix. Okay, since the magnetic field is applied along two direction, so on multiplying this, what we will get, sigma x and the component of magnetic field along x direction, that is b1 cos omega t, and sigma y by is 0, so sigma y by becomes 0, and plus sigma z and the component of magnetic field along z direction b naught. So sigma, sorry, here is z. Okay, this is z, it have become by mistake sigma z b naught. Okay, now we intend to study the time evolution of this Hamiltonian, for which now we have to study about the time evolution. we have to find the state vector, so that we can determine the condition of magnetic resonance and spin flipping like that. Okay? For that, time evolution of Hamilton, for which we have to use time dependent Schrodinger equation for spin degree of freedom. Means here we have to use study about only spin. So while considering the state vector, we will consider xi, which I have already discussed in previous section also. So we have to use time dependent Schrodinger equation. What is time dependent Schrodinger equation? I is equal to del psi by del t, or del xi by del t equal to this. H is already we have found. H, in place of H we have to put this Eg h square divided by 4mc sigma x b1 cos omega t sigma x b1 cos omega t plus sigma z b naught and xi t, that is state vector. Okay, so on solving, what we will get, h cut and h cut of both sides will cancel, and this I goes to another side, becomes minus I, because 1 divided by I means I to the power 4 by I, and I to the power 4 equal, from I to the power 4 1 I will cancel, and I cube remain. I cube means minus I, so that become here minus I del xi t by del t minus I e g upon 4 mc sigma x b1 cos omega t sigma z b naught, other as it is again in previous section. So again we will simplify this. In general, the state vector is, according to Bohm, it can be either up or down. So while representing state vector, we will represent it by Coulomb vector. Okay, 1 by 2 Coulomb vector of the order 1 by 2. And it is generally represented by c plus t and c minus t. So we use this in above equation. What we will get, in this side there is the derivative of this xi t, so we have to do derivative of both the term. So this would be c plus dot t and c minus dot t equal to minus I from previous section as it is, and e also from previous section, g upon 4mc. In place of sigma x, we have put the value of Pauli spin matrix along x direction. What is its value? Its value we have already found. Okay, you can watch in my previous video also if you become confused. So I have found, or we have found already, 10110 and p1 cos theta as it is plus, and this is the Pauli spin matrix along z direction. This also we have already found. It is found to be 100 minus 1 and b naught from before, and this xi t will represent state. Here also we have to put this c plus t, c minus t. I will put in another step. Okay, you can watch here. So this as it is, and we multiply by this. In place of eg b1 divided by 4 omega c, we can put omega naught. Sorry, eg b naught divided by 4 mc, we can put omega naught. This will represent frequency. Okay, frequency along z direction, strong frequency, it is very high. And in place of absolute g e g b1 upon 4 mc, we have put here omega 1, which is the frequency along x direction, that is variable frequency. And then on solving we can get this. Look, for example, you can see here in the first term, the x component will not appear because there is 0, but z component will appear as it is 1. So 1 into b naught multiply by this e g b naught divided by 4 mc will be omega naught minus I from here. Similarly, you can get all the component, and this last term xi t, c plus t, c minus t. Likewise here, on comparing the corresponding element, okay, here again multiplying by this minus I omega naught into c plus t minus I omega naught c plus t, and minus into plus minus I omega 1 cos omega t c minus t. Here also similarly we have used multiply, and then we have compared corresponding element here. So on doing this we will get this. Again we will rearrange the plus plus term, we will bring in same side, and minus minus term we will keep in one side, so that we can find their solution easily, or we can check either the solution are homogeneous or not easily. Okay, so for that we have taken this plus c plus t from this left hand side, so c plus dot t as it is, and this minus 1 goes to left hand side, becomes plus minus I omega naught c plus t becomes plus I omega naught c plus t, and this is as it is. Again for here also we have taken minus from in similar side, so c minus dot t, and then this plus goes to another side become minus, and this is as it is. Now we this will be needed later also, so we have numbered it as equation second. Okay, and from here what we can see, we can see that the solution of this equation are not homogeneous. So the solution would not be simple, their solution would be in the form of here I have done. Okay, both the equation in second are non-homogeneous, so the solution of above equation will be in the form, this plus would be c plus t. For simplicity we have assumed a plus t, we can assume anything here, a plus t e to the power minus I omega naught t, because you can look here, and this is plus none, so in this side that would be minus, so for this we have assumed c plus t equal to a plus t e to the power minus I omega naught t, not minus I omega naught t. Likewise c minus t equal to a minus t e to the power minus I, sorry, e to the power plus I omega naught t. Here this a plus t and a minus t are again time dependent, because the above equation are non-homogeneous. If the solution this equation would be homogeneous, then we will get the amplitude that would be independent of time. Since our equation are non-homogeneous, so here the amplitude vary with time. Okay, that I have written here, where a plus and a minus are the amplitude that vary with time. So on substituting this value of c plus t and c minus t in the above equation, this second what we will get. So the equation second will take the form, we have substituted value from here. In place of c plus dot t we have differentiate it. While differentiating we have to differentiate two time, because this also a plus t also will vary with time, and e to the power minus I omega t also will vary with time. So derivative of this what we will get, a plus t e to the power minus I omega naught t one time, and minus I omega naught a plus t e to the power minus I omega naught t, plus, and another term what is here, plus I omega naught c plus t. So plus I omega naught as it is, in place of c plus t we have put this value, okay, is equal to, and RHS would be same, in place of a c minus t I have put a minus t e to the power I omega naught t. Other everything is same, I omega naught minus I omega 1 cos omega t, and in place of c minus t what we have put, c minus t a minus t e to the power I omega naught t, that I have put. Other thing is same. Likewise in the second of this, in another equation of this second also I have done similarly. You can put the value of c minus t dot and c minus t and c plus t, and then you will get the equation of this form, in this form. On solving what we will get here, plus and minus term, these two terms are similar except in sign, so we can cancel these two, and here also this and this are similar except in sign, so we can cancel these two, and what we will get, a plus dot t e to the power minus I omega naught equal to minus I omega 1 cos omega t a minus t to the power minus I omega t, and here also a minus dot t e to the power I omega naught equal to minus I omega 1 cos omega t a plus t to the power minus I omega naught t. Now what we can see, again these two both of these equation consist of cos omega t term or not, and we already know the expansion of cos omega t term, so we will do that. At first we will take this e to the power minus I omega naught to another side and make it plus, and here we will take e to the power I omega naught t to the another side and make minus, so that in power we will get e to the power I 2 I omega naught t in this, and here we will get e to the power minus 2 I omega naught t So we will make this term simpler, okay, by introducing the value of cos omega t, and then we will introduce new frequency. And we always know in the precision frequency should not exceed the Larmor frequency. By using that we will mm, remove one frequency. For that we will make it the power here e to the power 2i omega naught t, and here e to the power minus 2i omega naught t. Okay, other everything is in this term goes to the other side, and we have arranged this became and that. Again, we also know that cos omega t expansion of cos x. What do you know? Cos x equal to e to the power minus e to the power minus ix plus e to the power ix upon 2 or not. So here we have done that. Cos omega t equal to 1 by 2 e to the power x plus e to the power ix plus e to the power minus ix by 2. So we have applied that in place of cos omega t. On applying this on the above equation third, we will get what we will get. You can solve this, okay. If you become confused, you can solve. In place of cos omega t, we have put 1 by 2 e to the power I omega t plus e to the power minus I omega t. Okay, so 1 by 2 will come front side, so it will be minus I omega 1 upon 2, and one time this power would be greater than the frequency would be greater than 2 omega naught, which is not possible. So that we will neglect, that we have neglected, and then only the power containing minus term we have used here, and it have become minus I omega 1 by 2 a minus t e to the power I 2 omega naught minus omega t. We have made that. You can say minus I omega 1 upon 2 a minus t to the power I 2 omega naught minus omega t, since the frequency cannot exceed the Larmor frequency. So that we have made here, and in another term also there is minus, and here in bracket we have done the same. Here we have removed minus term. In this previous we have removed plus term, and here we have removed minus term. So the equation third will take the form of this. Here the frequency cannot be above Larmor's precision frequency, so the new frequency cannot exceed 2 omega naught. So the equation have taken the form of this. Now again, for finding this a minus t and a plus t, we will again differentiate both. Since we will again differentiate both, and what we will get on differentiating the first equation of IV, if we differentiate this equation, what we will get? A plus double dot t equal to, and this term is constant and this vary with time, so we have to do derivative of this both of this term, minus I omega naught upon 2 a minus t dot, and another same. Again we will do the keep this same, and we will differentiate this. So omega 1, while differentiating this we will get I 2 omega naught minus omega r naught. So here I, and here minus I into minus I, that will be minus I square, which is equal to plus. So plus became an omega 1 and 2 omega naught minus omega divided by 2, this divided by 2, and other a minus t x, the derivative of e to the power iax equal to what? Ia e to the power iax. So this became like this, or not? Okay, now here is a minus t dot term, which we have already found in terms of a plus t or not. So in place of a minus t dot, we can put value from here. What we can put? 2i upon omega 1 a minus, sorry, we can put value of a minus t from here. Okay, we can put this in place of a minus t. Again here is a minus t, whose value we can find from here. A minus t we can find from here. By rearranging this term we can find value of both of these. So we can simplify this b by using iv, rearranging equation iv and using in b. What we will get? A plus double dot t equal to, we have rearranged that. You can check this by yourself. How we have arranged to carry minus I omega 1 by 2 as it is a minus t dot. A minus t dot equal to how much? We have put this value. In place of a minus t dot we have put this value, and this other same in first, and in second this we have kept as it is, and a minus t we have put from here. 2 divided by minus I omega 1 e to the power minus I 2 omega naught minus omega t. We have put that, and then another term is here same. So in both the term containing the power of e will vanish, I think. That term containing the power of e will vanish, and then you will get the equation of this form, where all the terms would be in the form of a plus t. Here is also a plus double dot t, and here what we will get after arranging minus into minus, plus I square minus 1. So minus became omega 1 into omega 1 square, 2 into 2 4, and a plus t, and here is what is here is 1 divided by minus I, that would be I, and this is 2 and 2 cancel, omega 1 cancel, I 2 omega naught minus omega from here, and then a plus t dot, Now we can see in this equation all the term will contain the a plus t r naught. So with this equation became homogeneous. On taking all the terms in same side, what we will get? A plus double dot t minus I 2 omega naught minus omega a plus dot t plus omega 1 square upon 4 a plus t equal to 0. Here all the terms consist of a plus t1 terms, so we can say that this is homogeneous, so its solution would be a little bit simple. This equation is homogeneous in a plus t, so it must have time independent general solution, okay, or homogeneous solution, we can say that. Homogeneous, so it can have simple solution, time independent solution. So a plus t, for a plus t we can write a plus 0 e to the power, there is minus 1 term, so for plus 1 you have a plus t equal to a plus 0 e to the power I lambda t, where this a plus 0 will not depend on time, okay. Here a plus 0 will not depend on time since it is non-homogeneous. Now on solving this, we can find a plus dot t from here and a plus double dot t also from here, and we can put that values in equation vi. Substituting this equation in vi, what we will get? First of all you have to find double dot. For that, minus, what we will get in single dot, I lambda a plus 0 e to the power I lambda t, and again I lambda my I square lambda square, or not I square equal to minus 1, so minus lambda square a plus 0 e to the power I lambda t here, and again here is minus, and from here minus I 1 I lambda we will get, so minus I square plus minus, that would be minus into minus plus, so here become plus, and other same lambda you will get, and a plus 0 e to the power I lambda t. Likewise this also same, a plus t1 value you can put from here, and on solving we will get this. But all of these term consist a plus 0 e to the power I lambda t common. We can take that outside and we will get something in bracket, or not. We will get this term in bracket, since this a plus 0 is state which cannot be 0, which cannot be vanished, and e to the power I lambda t also not equal to 0. So we have to have this term equal to 0. Now it seems quadratic in lambda. This equation seems quadratic in lambda, so we can find its general solution, which will have two roots, we already know. Okay, this equation is quadratic in lambda, so it have two roots. Yes, how we can find the roots of quadratic equation? Ax square plus bx plus c equal to 0. We will find x equal to minus b plus minus root under b square minus 4ac whole upon 2a. So we have used the same formula over here to find the roots. Okay, and for that two roots we have represented by lambda plus and lambda minus. This caused the general solution of a plus t to be in the form Previously we have assumed that the general solution of a plus t equal to a plus 0 e to the power I lambda t, or not. But as this equation will have two roots, so the general solution should be in the form of two terms. So we have assumed this a plus t equal to a e to the power I lambda plus t plus b to the power I lambda minus t. Okay, from here what again we will what we did again using IV we can get in IV what we have found. In IV we have found the relation between a plus t and a minus t, or not. IV you can see here what we have found, a plus t and a minus t we have relation. So from here if we have found a plus t, then we can find its derivative, or not. A plus t one derivative we can find, and then we can multiply by some term, rearrange this, and then we will find the value of a minus t also. So we have done that here. A minus t we have found, done cross multiply and then done derivative of this. Since this term is independent of time, we should, it is not necessary to do derivative of this because the derivative of this is already 0, so we can do derivative of this. So while doing derivative what we will get, I lambda plus a I lambda plus e to the power I lambda plus t, a I lambda plus e to the power I lambda plus t, and for doing this derivative b I lambda minus e to the power I lambda minus t, b I lambda minus e to the power minus I lambda minus t, and other term we have rearranged from bi, sorry ib. On doing that you will get its value. So again if we substitute its value, then what we have for general solution of state c plus t and c minus t also we can get, not c plus t what we have assumed the general solution of c plus t was a plus t uh, e to the power minus I omega naught t, or not. So we have found a plus t, we have put the value of a plus t over here, and c minus t what we have assumed, c minus t was equal to this. Here you can see in equation 1 I think, in equation 1 we have found c minus t equal to a minus t to the power I omega naught t, a minus t I have found here, a minus t put from here, a minus t put from here, and other put in equation 1. So we can find the value of c plus t and c minus t also, but here still we have to find the values of this a and b, what these values are. For that what we have to do, that we have to assume some condition. Okay, now it remains to find the values of amplitude a and b. For that we assume initially at t equal to 0 the electron is in off state. Okay, so for the determination of the amplitudes a and b which are independent of time, we have to assume initially at time t equal to 0 the electron is in off state. That off state means c plus t equal to 1 and c minus t equal to 0. We have assumed that xi t equal to c plus t c minus t equal to 1 0. So from this what we can do, c plus t c minus t we have found, or not. Here we have found c plus t c minus t, here we have found. So in place of this we can put is equal to 1, and in place of this we have to put is equal to 0, and in place of t we have to put 0. So on doing that what we will get from this upward term, we will get a plus b equal to 1, and from this downward term we will get ai lambda plus bi lambda minus equal to 0. Since this is constant, that already became 0, or not. A plus b equal to 1 we will find, and a lambda plus I also we can cancel, since it is not 0, constant term will vanish. Okay, so on solving this, a plus b equal to 1 and a lambda plus b minus lambda equal to 0, what we will get, we will get the values of a and b. A equal to lambda minus divided by lambda minus lambda plus, and b equal to minus lambda plus divided by lambda minus lambda plus. What the value of lambda minus and lambda plus we have already calculated, or not? Here we have calculated, so we can simplify this. We can simplify we can find the value of a also and the value of b also, and after finding its value we can put this in the above equation, this ix, and then we will find the value of state at any time. We have done that. On substituting this value, the general solution became c plus t. In place of a we have put lambda plus or divided by lambda minus lambda plus, and in place of b we have put minus lambda plus divided by lambda minus lambda plus. Okay, on solving this we have got c plus t and c minus t. Okay, now this is our solution. This is the general solution. Again we also want to know that if the initially the electron is in up state, then at which time the electron will be in down state. For that we have to determine the probability of c minus t. Okay, spin flipping. Now we intend to determine the condition of spin flipping. Again, if we intend to find the time after which the spin flips, at that instant the probability of finding the probability in down state is 1. If we intend to find the spin flipping, as we have assumed that the electron is in up state at initially or at time t equal to 0, so we became curious to determine at which time the electron would be in down state. For the electron to be in down state, the probability in down state should be equal to 1 or not. We have used that condition for finding the probability in down state, that is c minus t whole square equal to 1. This is the formula of probability, which is equal to, how we will determine this, c minus t into c minus t complex conjugate. So on doing that, what we will get, c minus t into c minus t complex conjugate. How I have to solve, I will tell here. C minus t, this term would be, this is real, so for c minus t and c minus t complex conjugate it will be same. So minus into minus will be plus, and 2 into 2 4 divided by omega 1 square. 4 divided by omega 1 square come from that. Okay, and another here we have found the value of this also and this also, where both here also lambda minus lambda plus divided by lambda minus lambda plus, here also lambda minus lambda plus divided by lambda minus lambda plus, and both of these are real, so we can take them outside. Lambda minus lambda plus divided by lambda minus lambda plus, and in both equation the value would be same, so we can write their square directly. Okay, so I have done here the same. Lambda 1 lambda 2 divided by lambda 1 minus lambda 2 whole square. But how I have written this directly, omega 1 square divided by this. In place of lambda 1, what is there? In place of lambda 1 there is 2 omega naught minus omega lambda minus lambda plus lambda minus 2 omega naught minus omega minus root under 2 omega naught minus omega plus omega 1 square. From here you can see lambda minus equal to 2 omega naught minus omega minus root under 2 omega naught minus omega 1 square plus omega 1 square upon 2, and in place of plus there is plus, so you can do multiply directly. While multiplying, what would be there? A minus b, a plus b, a minus b, a plus b means a square minus b square. On doing that, what we will get, this 2 omega naught minus omega square, and here would be another 2 omega naught minus omega square, whose sign would be different, so they both will cancel, and minus omega 1 square will remain from numerator, and downside there will remain 4 in lambda plus lambda minus. So I have written omega 1 square upon 2. Okay, omega 1 square omega 1 square divided by 2 omega 1 square divided by 2 from there to k. Sorry, 4 omega 1 square divided by 4, 2 into 2, 4 became, denominator 2 into 2, 4 became omega 1 square upon 4. And downside there was lambda minus lambda plus, or not? Lambda minus lambda plus. So lambda minus lambda plus, what would be? Lambda minus, this would be minus, and another also, another plus. So what we will get? Lambda minus means 2 omega naught minus omega minus root under 2 omega naught minus omega whole square plus omega whole square minus 2 omega naught minus omega minus into minus would be plus. Sorry, there would be in plus term there would be plus, so minus into plus minus there would be, and this first term will cancel as there would be 1 plus and 1 minus, and another minus 2 root under 2 omega naught minus omega square plus omega 1 square divided by 2 will remain in denominator, so 2 will cancel from numerator and denominator. So in this case we will get minus root under 2 omega naught minus omega square plus omega 1 square, as we have got minus in numerator also and in denominator also, so that minus of numerator and denominator will cancel. That have happened, and in denominator only this remain, and lambda 1 minus lambda 1 lambda 2, sorry, lambda minus lambda plus divided by lambda minus lambda plus in both, which is real, so we have to do square here. From that, this is a little bit lengthy but confusing, but it's here. Okay, so this also gone outside, this also gone outside, and this is a whole term, and this is a whole term, so one time it will be plus and another in complex conjugate this will be minus, so this term would vanish, and only the term of this term inside bracket only remain. So one time it will be e to the power I lambda plus t minus e to the power I lambda minus t, and next time it would be e to the power minus I lambda plus t minus e to the power minus I lambda minus t. So we have done that, e to the power I lambda plus t minus e to the power I lambda minus t and e to the power minus I lambda plus t and minus e to the power minus I lambda minus t equal to 1. Okay. Again we simplify other term, we will keep as it is or simplify it. This 4 square, that would be 16, and 16 and 4 4 will cancel and only 4 remain here, omega 1 square whole square, and here omega 1 square means omega 1 square cancel and omega 1 square only remain, and this square becomes this root n square will cancel. Okay, and we have multiplied time by time. Okay, so this into this, power term 1 is plus, another is minus, something power 0 became 1. Likewise this into this also, minus into minus plus, e to the power I lambda minus t into e to the power minus I lambda minus t means e to the power 0, that also became 1, and multiply this by this, plus into minus e to the power I, here minus I, so e to the power I take common, lambda plus minus lambda minus t, I lambda plus minus lambda minus t, and here also this into this, plus into minus e to the power minus I lambda plus minus lambda minus t, okay, equal to 1 is equal to, again solve this previous, this front one term I have kept as it is, 1 plus 1 2 minus e to the power I lambda plus minus lambda minus t. What happened down there? Minus have been taken outside common, so this became plus. Okay, and this term look like in the form of e to the power ix plus e to the power minus ix, which is equal to how much? 2 cos x, or not? So 2 cos x means 2 gone here, 2, and cos x in place of x, what should be here? What should be here? Lambda plus minus lambda minus t. So lambda plus minus lambda minus would be this which we have already found here. Here we have found lambda minus lambda plus, so here I have come minus sign also, as I have discussed before, but here is lambda plus minus lambda minus, so here would be no minus sign. And these two from here 4, from here is 4, so if from here will be 2 and here also is 2, so 2 common taken outside and 2 and 4 cancel, and here only 2 remains, so these 2 we have brought in denominator of this second term. So for this equation should be equal to 1, what should be, both of them should be equal to 1. For that, for making this first term equal to 1, what we should have, we must have 2 omega naught minus omega equal to 0, or omega equal to 2 omega naught. Okay, for this to be valued, both terms should be equal to 1. For that, 2 omega naught equal to omega, and from another term what should be there, and in this term here is 1 and this should be minus 1, or this should be minus 1 to make it 1. 1 minus minus 1, that would be how much, 2 divided by 2, that would be 1. So for making this minus 1, this 2 omega naught minus omega would be 0 from here. So in place of here there would be 0 and omega 1 square, and root, from square and root cancel, and omega 1 t remain here, cos omega 1 t. So we must have the value of cos omega 1 t equal to minus 1, alright. Cos omega 1 t equal to minus 1. And what is the cosine angle for minus 1 value? That cosine angle is pi, 180 degrees. So in place of minus 1 we can put cos pi. By comparing corresponding value, what we get, omega 1 t equal to pi and t equal to pi divided by omega 1. So we have assumed that after time t the probability of finding the electron in down state is 1, or not. So the time of spin flipping is what is, pi divided by omega 1. So if the probe frequency is omega 1, uh, after time t the state would flip and come to the down state. Okay, by knowing that you can find some idea about the magnetic resonance imaging, which is used in medical purpose. It is the theory behind that. Okay, we generally know about the machine, but we don't know how it works, and this theory would enable you to know about the theory behind that experiment. Okay guys, this much for today. Don't forget to like, share and subscribe my YouTube channel.